There's something not quite right about the way that we're building AI models. We have pretty much every single CEO of all the big AI labs talking about AGI and these super intelligent systems we just don't understand, we can't control, we can't steer, we can't shape and mold as our own. And it just seems deeply irresponsible to me to be able to deploy all of these systems in mission critical contexts without a deeper understanding of kind of how these models work.
How urgent is the need, really, or what makes it so urgent? What are we risking here if we don't figure this out?
Never before has there been such a big gap between how widely a technology is being deployed and our understanding of this technology. We can extract a lot of concepts from models right now, but it's also just a really hard problem. I wake up every single day and I think about interpretability.
What would you say makes this team so special to you?
Pretty much every researcher gets offers from Anthropic, DeepMind, OpenAI, and they choose to come here and take a pay cut to come here. In many ways, I think of what we're doing as building a bridge between an AI mind and ourselves. That's the path that we're going to take. No matter what, we're going to make this happen.
Hi, everyone. I'm Nnamdi Iregbulem, a partner at Lightspeed, and this is the Investment Memo, the show where founders reveal the stories behind the businesses they are building and how they will shape the future of their industries. Today, I'm joined by Eric Ho, the co-founder and CEO of Goodfire, a company redefining how we understand and steer the behavior of large AI models. Goodfire is a pioneer in the field of interpretability, opening the black box of neural networks so we can understand, debug, and intentionally design AI systems. Today, we're hearing from Eric on why researchers don't necessarily understand their own AI creations, the urgency of interpretability, and the role it has to play in building the future of AI. Eric, welcome to the show.
Thanks so much for having me. Excited to chat and dig in here.
Massive congrats on everything that you've accomplished with Goodfire to date, and then in particular, the Series B fundraise that you're announcing, 150 million Series B fundraise. That's no small accomplishment.
Yeah, thanks so much, man. And I mean, we're just getting started, though. It still feels like such early days. And I feel like the larger the number, the more it's a message of just, you got to get to work here. And I feel like it's still just the beginning of building something great.
Founders usually never get to see their investment memo, but here today you get to see the memo, and not just the memo, but how it changed from the seed round that we originally led up until the Series B today. You ready to see it?
Yeah, let's do it. I've never seen one of these before. I'm super excited to dig in. I've raised a lot of rounds of capital, so here we go.
We'll talk about a bunch of things today, but I think one of the things I want to point your attention to that we'll talk about a bunch here is the investment thesis section.
Okay.
Obviously, the story has evolved a lot since the seed round, but just to kind of frame up how we originally talked about the company, if you recall, you remember this idea of software 2.0 that we talked about a bunch, that we need new tools to kind of work with this new form of software. And so I thought a good place to start, just kind of the current moment that we're living through, right? So we're in this big AI moment. AI has become this ubiquitous new form of software, as we were just saying, impacting the world from healthcare to heavy industry to hardware, et cetera. But even today, researchers are not totally able to understand their own creations and control the behavior of these models.
Yeah, they know almost nothing about it.
And so scientists and the general public alike are really worried about, where AI will be applied in the future, where it's all headed. And so in April of 2025, Dario Amodei, the CEO and co-founder of Anthropic, published was a really interesting essay called The Urgency of Interpretability, where he described a case for why AI will go a lot better if models are interpretable. And he pretty strongly states that we're in a race between interpretability and model intelligence. I thought this was a great essay, and in two lines I think are worth, kind of quoting. People outside the field are often surprised and alarmed to learn that we do not understand how our own AI creations work. They are right to be concerned. This lack of understanding is essentially unprecedented in the history of technology. So I thought maybe you could kind of frame up the current moment for the audience and kind of explain, what is it that we don't understand about AI models?
I loved the essay, and I think it was apt and just an important one, and mirrors a lot of my own thinking about kind of the field. And I think really never before has there been such a big gap between how widely a technology is being deployed and our extremely limited understanding of this technology. And I think that gap is only widening as AI models get increasingly capable and widespread, in charge of increasingly kind of mission critical and important applications in day-to-day society. I think the reason why I'm building this company, my co-founders, every single person at the company, we really just saw kind of a future where AI models were getting increasingly capable, unlimited scale, increased compute, more data. Yet, like, nobody understood kind of what the nature of this intelligence really was. We didn't understand how these systems worked, and we didn't understand kind of, if we put in this set of data, this is what comes out, this is the representations that happen in the model. And it just seems deeply irresponsible to me to be able to deploy all of these systems in mission critical contexts without a deeper understanding of kind of how these models work. There's just something kind of messed up and not really right there. That was kind of the original thesis behind starting this business and building here. And I think it's just a feeling really shared. I think a lot more widely than just in our company as well.
How urgent is the need really, or what makes it so urgent? What are we risking here if we don't figure this out?
I think that AI is going to have massive consequences on society and it'd be enormously transformational. I mean, we have pretty much every single CEO of all the big AI labs talking about AGI, superintelligence. When we think about a system that's smarter than us, you and me, every single person we know at everything, that type of system and that promise, and also just like the widespread job loss that will occur as a result, and talk openly about that. The systems that are going to become, these super intelligent systems we just don't understand, we can't control, we can't steer, we can't shape and mold as our own. I just think there's a huge disconnect that to me is unacceptable. I feel a deep kind of obligation to go and actually kind of craft and shape these systems such that we can actually understand them and really be able to intentionally design them. And so I think that probably these AI systems will get, to human level intelligences with or without interpretability. But I just think that we'll be able to much more effectively kind of steer and control these models if we understand them.
Totally agree. One of my favorite metaphors that you've used throughout the lifetime of the company is the idea of a bonsai tree as a sort of metaphor for interpretability. I think it's been in pitch decks. I think it's been in board decks. Really gone far and wide with the
We
bonsai.
got deep with it.
Yeah. Maybe tell us a bit more about what you mean when you kind of analogize to the bonsai.
I think of the systems that we're creating today as the products of scale, data, compute, and just like a lack of understanding of the AI models that we're building. And so you can get lots of unintended consequences of these systems. Like you got Mecha Hitler coming out from Grok, and you have all sorts of weird behaviors of models like sycophancy and 4.0 that you can't really intend. And we really see a future where we can actually shape these models as they're being trained, as they're being grown, such that we can actually put the stuff that we really want inside these models and actually gain trust over kind of what we really have inside of these models. So I kind of think about the current way of building AI models as growing this like massive tree, and it's all wild and knotted and gnarly, and it's like the Whomping Willow in Harry Potter, smashing around. And really, like, the future we want is craft shaping, kind of really intentionally, almost like lovingly crafting the systems that we want that can actually serve humanity and really be aligned kind of with our values and morals that we really care about. And I think that's really the future that I want to live in, where we can deeply trust the AI models that we deploy, really, really everywhere.
And I don't know anything about taking care of actual trees.
I don't either.
Yeah.
Yeah, the plants in my apartment die.
Yeah, I was gonna make the same joke. But it's hard, and I think it's fair to say interpretability is not easy either. What is it that makes looking inside the black box of these models so difficult?
Interpretability is a hard problem. These models are getting really big. The most recent models that some of the recent models that we're working with, Kimi K2 thinking, that's a trillion parameter models. Trillion is a big number. And when you look inside the code of an AI model, set of weights and parameters of the model that don't mean anything to the human eye. They're just a bunch of random looking numbers that you can't make heads or tails of, that you can't read, that you can't hand code or program. When you think about it, it's, of course, you can't architect and craft this software effectively with high reliability if you can't actually debug the software. You can't even look at it. You can't edit it. We're missing kind of this fundamental set of tooling that allows us to actually gain a good and deep understanding of these systems. So we lack the fundamental primitives for intentional design.
I want to kind of turn back the clock a little bit to a primitive era in interpretability. If you think back to, convolutional neural nets when they really started to take off in the era of, vision and computer vision, and you could see in some of the later layers of these models, like these different, whether they were shapes or edges or different kind of features that these models were picking up at different, layers of the
Like
network.
edge detectors and
Yeah, exactly. In a sense, that was interp,
mm-hmm.
but obviously we've come a long way since then.
Yeah.
It'd be helpful if you could give maybe just an overview of the kind of history of interpretability. In particular, maybe highlight what breakthroughs really made it clear to you that there was something here, that we would eventually be able to understand these models.
I think of interpretability as three eras, and it's a really young field in terms of maybe modern neural net interpretability of kind of deep neural networks. There was really nothing to interpret before there were really interesting deep neural networks that we were about to deploy across the world. So this is kind of why the field is pretty young. But I would say that kind of this strand of thought started at OpenAI with the Clarity team that was started by Chris Olah, who's now a co-founder of Anthropic, and Nick Camerata, who's one of the early members of the Goodfire team and was really influential in kind of shaping the early days of the business. And they were primarily studying vision models and really trying to understand Inception V1, which is this like tiny little image model for image classification. That is probably the most studied neural network really ever. And what they kind of posited with their kind of really influential circuits thread was that there are features inside these models that you can kind of extract and understand that these models were actually doing something rather than just kind of like randomly applying a bunch of heuristics. Two is that there are circuits, so features that kind of fire together such that you can form more complex concepts. Like the example that they used was a window detector and a tire detector and a couple other things combined to be a car detector. And that's a circuit, a set of features that fire together. So maybe that was like era one of interpretability. Era two is paradigm of training this type of interpreter model to extract concepts from these models. So when you look inside models, they're almost like giant compression algorithms that compress the entirety of the internet into a relatively small number of neurons and parameters. And what this often results in is these neurons and parameters, multiple of them fire kind of at once in order to form like a higher level concept. And often each neuron is also responsible for encoding multiple concepts at once. To resolve this, a couple folks, I think it was Lee Sharkey in a group at Apollo Research kind of proposed applying sparse autoencoders to language models to essentially map these concepts to a higher dimension of clean interpretable concepts. Anthropic also, I think around that time, was also thinking about sparse autoencoders and then popularized it with Golden Gate Claude. And that's maybe like second era of training this type of interpreter model to extract concepts. I hope that we're kicking off really this third era of intentional design. This is not fully released yet, but more will come soon. But we figured out a lot of the core problems with steering and guiding the training of models using the interpretability techniques that we've developed. So really this era of like kind of like a bonsai tree, how do you actually prune and shape a model during training such that we can precisely edit these models, get the representations that we want, and actually gain trust over the training process. Maybe like underlying all of that too is this concept of AI agents being able to do everything. So I think GPT-4 was also kind of an inflection point where that was the first model that could describe neurons of another model. And so there's almost a really helpful recursive element to interpretability that with increasingly powerful AI systems, we are able to automate more and more interpretability techniques, because when you're looking at a trillion parameter model, you can't describe what every single neuron does. It's a trillion. It's way too much. So this idea of automated interpretability that Nick Camerata kind of pioneered at OpenAI was also kind of like underpinning really everything. Like, given enough time, all supervised techniques become unsupervised with AI.
Amazing history lesson, Professor Ho. Well, I want to turn from the history of interpretability to the history of you starting the company. So in 2023, you stepped down from your executive role at your last startup, Ripple Match. And I think it was around that time that we met, batted around, various ideas. It was very clear to me how passionate you were about AI. And it was in June of 2024 where you raised the seed round that Lightspeed led to build this set of AI interpretability and model editing tools for large AI models. The idea really resonated with me as someone who spent a lot of time in, kind of classic developer tools, because you were basically saying like, hey, you should be able to directly modify these models and their behavior in a precise atomic way, in the same way that we do with, traditional software. And so I'm curious, like, what got you to start the company? Of all the things you could have done, why this company, Interpretability, Goodfire?
I left my last company because it just, something didn't sit right with me, that we were about to kind of deploy these massive AI systems. And I just kind of saw the future of scaling laws and scaling up compute and resources to build better and more capable systems. And we didn't understand them. And that something just felt deeply wrong to me as a developer, as an engineer, that we're just going to kind of go and release these systems that we don't understand out into the wild. And so the concept of interpretability was always like really, really interesting and big if true. The real question, the load-bearing part, is the if true statement. And so a large part of kind of my journey between the transition and kind of officially starting the company was kind of getting over a lot of these hurdles. Like, could we actually make the technology work? In order to gain confidence there, I, in short, just talk to people much smarter than myself in the field of interpretability. So Nick Camerata was influential. My co-founder, Tom, who founded the interpretability team at Google DeepMind, was really helpful in forming the early concepts, ideas. Lee Sharkey, who we just mentioned, who kind of pioneered a lot of the use of sparse autoencoders on interpreting models, introduced me to Tom, and is now the head of our London team. These folks and the kind of passion and clarity of the future that they saw really helped me kind of get over all of the kind of doubters and in the field. And also just like, I feel like we've done harder things than interpret neural networks. We like sent rockets to space. That seems harder to me. I think I just felt like a tractable technical problem that we can go and solve.
That's awesome. So anything less hard than going to the moon, you're willing to do?
Pretty much, yeah.
I know you gave us some credit for our original sort of investment thesis being relatively consistent to how you sort of think about things today. But, visions evolve over time, and it's never, you never capture it perfectly at the genesis. So I'm curious, maybe you could articulate what was the original vision, and how would you define yourself today, if at all differently?
I think it's largely similar, in that kind of the huge unlock is still, how do you articulate the science of neural networks such that we can intentionally design better, safer, more powerful AI systems that we can really kind of deeply trust? I think one thing that we didn't anticipate was how useful this would be in non-language modalities as well. So we do a lot of work with life sciences and genomics and epigenetics, digital pathology. It's starting to work with perturbation models. So a lot of really interesting things there. And also in kind of image models. And there's a lot broader kind of usefulness to interpretability than originally anticipated, interpretability tooling. It's also just a really hard problem. So we've spent a lot of the first 18 months of the business building the best frontier interpretability research team that can really push the frontier of what we really know about these systems. And it's still largely an unsolved problem. The amount of greenfield is still staggering in the field of interpretability. So we just need a lot more people to kind of like answer the call and really deeply try to probe and understand what's actually going on in these systems.
One of the things you alluded to there was, I think it's been true about Goodfire since the start, is that you always sort of are ahead of the game as far as how the rest of the world and the rest of the market is thinking about the applicability of this technology. Why do you feel like interpretability is ready for commercialization?
Back then it wasn't, in short. So we had to kind of create the market, create the tooling, do the research that was necessary in order to kind of cross the chasm of building really anything of value. And there's still so much more work to be done there, even on the research side. Yeah, it was a lot of work to kind of get us to the point where we could monetize even something and commercialize it. But I think we've gotten to the point where now we have a whole platform for model design where you can intentionally design your models and understand them and interpret them and modify them. I think it was just a bet that we'd get there someday,
Yeah.
and it was a little faster than I actually guessed at the time. I thought we were going to be trudging through the mud for a few years before we would get anywhere interesting.
It's a fair point. When you started the company, it was early.
I think I told you that we were going to trudge through the mud for a couple of years, and that's the path that we're going to take. No matter what, we're going to make this happen, no matter how long it took.
You mentioned the platforms. Let's talk a bit about that. And so back at the seed, I mentioned we had been talking about this idea of software 2.0. And so in September 2024, you launched the first version of Ember, which was really the first hosted interpretability API. And the idea being to allow engineers to, in some sense, decode a model's thoughts
Yeah.
and give direct, programmable access to those internal representations.
Mm-hmm.
How different is interpretability to prior ways to sort of direct the behavior of models? What are the kinds of things that a customer of Goodfire, user of Goodfire could do that maybe, I don't know, traditional fine tuning couldn't achieve?
Yeah, so first of all, I still kind of like IDE for software
I
2.0.
love that.
I still really like that.
Vindicated.
Yeah, I still kind of like that it indicates that there's some set of tooling and primitives missing that we really need in order to engage with models as we could with written software. So the primitives are still, yeah, like understand, edit, and debug this set of technology. So it depends on kind of the modality that we're working in for what's kind of most useful, but you can kind of think about our product as really a model design environment where you have access to all of these new sets of primitives that you otherwise wouldn't have access to before. It starts with training this type of interpreter model in order to almost like map the mind of the model, map the loss landscape, such that we actually understand, what's actually going on inside. What are the mechanisms of action inside of these models? Then we want to explain kind of once we've mapped these mechanisms and concepts, like what do they actually do? What are they? How can you use them? And now that we have this set of primitives, we can then kind of combine them, use them to monitor the model, use them to intentionally design them and train them and align them to what we want. Maybe a couple examples. Mayo Clinic and Arc Institute and one of our partners, Primamenta, in the life sciences space. Maybe zooming in on Primamenta, they have an epigenetics foundation model that they're training in order to solve and cure neurodegenerative diseases like Alzheimer's and Parkinson's. And their model is state of the art at early diagnostics for Alzheimer's. So we've first started by, mapping the mind of that model, what's actually going on inside. It's state of the art, so we know that there's something in its weights, parameters, neurons that makes it better than, our current understanding of Alzheimer's. And in doing so, in actually being able to explain what's going on in the model, we could help them, one, debug it, make sure we can remove confounders, because typically in healthcare, you're dealing with noisy and sparse data. So we can remove the bad stuff that it uses that it shouldn't be using in order to generate a prediction, and also uncover why it's superhuman. Why is this model special? And in doing so, we've actually discovered a new biomarker for Alzheimer's with them that I think maybe by the time this is out that we'll have announced. It's just hugely exciting, and I think is the first instance of new scientific discovery in the weights of a biology foundation model, and that's just the first of many, many more to come.
Yeah. I really personally love the life sciences use cases. In our original investment memo, that was not there. That wasn't.
Isn't there?
It was. But it's really interesting, right? I mean, in some sense, again, I think it's well aligned with just sort of the story of interpretability, which is that it's always more useful than people think.
Mm-hmm.
And this idea that, I think in traditional LLMs, because we can read what the model is saying, you can kind of convince yourself that you understand what it's thinking. But in these other domains, these other areas where the model isn't speaking English, it's speaking, DNA sequences or whatever it is, interpretability is the only way
Yeah.
understand in some sense what that model understands and why it's doing what it's doing. And it's especially critical because, as you mentioned, with some of these organizations you're working with, I mean, these models either now or in the near future will be superhuman in those domains.
Mm-hmm. Yeah. Already are in so many ways. And yeah, when you're trying to train a model and it doesn't speak English and it only speaks nucleotides, it's like pretty unhelpful.
Yeah.
And so,
Biology was my worst science. So that's, really helpful to me in particular.
yeah, unfortunately, it was mine as well. So, but yeah, I think it's just critical for all of these, non-language modalities. And people think AI. Most people just think ChatGPT right now. And so, I think there's just so much more that we can help with. So right now, we spend most of our time working with biology and biological domains, as well as in language still. So that's the two primary use cases.
You've talked a bit about the team already, but I want to kind of double click on that because it is, I think, one of the most special things about the company, and it's evolved a lot since the early days. From our original seed memo, in the you got a team section, and I think a direct quote: "Goodfire hopes to grow the team to 10 in the first year, largely focused on research and engineering. We are now, 18, 20 months on or so. How big is the team today?"
It's around 40 people, growing very, very quickly. I think in a year we grew the team to it's like 20, 25 people. Much faster growth in recent months, and have hired a lot of the folks that we were talking about targeting, like Nick and Lee, and just kind of a lot of the early pioneers of the field of interpretability. So
Were you expecting to grow this quickly?
no, I thought it would take a little bit longer in order to both convince these folks to join and also to push forward the research to the point where we could to an inflection point where we can kind of go out to market and commercialize.
What would you say makes this team so special to you?
I think that all of us are kind of unified by this belief and this mission that there's something not quite right about the way that we're building AI models today. It feels reckless. It feels like the only thing we care about is scale. And I think scale is deeply important and kind of the magic behind how this intelligence is formed. But there's almost a lack of curiosity with most researchers today. Like, why? Why is this happening? How can we possibly have these enormously complex alien minds almost like crash landing on Earth and not be curious about this? So it's both like a deep curiosity, but also kind of like a shared vision of a future where we just really want to knock the world to a future where we actually understand the systems that we deploy. And I think that's just a shared feeling from every single person in the team, and a really special place to be because there's both like a lot of joy and awe that we get from kind of just looking around and seeing the moment of time that we're in. It's just so fun, like thinking about how these models think and work. There's something deeper there. There's like a obligation or responsibility for us to kind of push forward this science, because we also see how things could go very wrong without our contributions.
What is it about the independent context in which Goodfire operates that lets you have the impact that you've been having and that you will have?
Pretty much every researcher gets offers from Anthropic, DeepMind, OpenAI, and they choose to come here and take a pay cut to come here. And I think it's increasingly obvious that this is the place to kind of build towards the future vision of intentional design. I think it's a research agenda that the other labs probably don't share. They view interpretability a lot more as maybe like a post hoc auditing technique, whereas we really view this as kind of the key lever to crafting and shaping these models intentionally, and kind of the major unlock that we actually need in order to design these systems effectively and safely. I also think we have a big advantage in that this is everything that we think about. I wake up every single day and I think about interpretability, and I think that that focus gives us a huge advantage. Our infrastructure is set up top to bottom through the lens of interpretability, which requires like access to intermediate layers of models, and that's not really easy to get when your entire infra stack is optimized in a really different way when you're at a big lab. So we have a kind of core technical advantage in kind of what does a bottom-up organization look like.
And just to hit on that again, just to give you guys credit for being early and being willing to do this independently. Another just quote from the memo. Goodfire has the opportunity to pioneer a new category centered around interpretability tooling with the potential to become an essential building block for responsible AI adoption and deployment.
All right.
Goodfire is an early mover in this space, which has historically been the domain of AI research labs, but finally seems ready for productization and commercialization. And so that leads to the first fundraise. And so, Lightspeed led your seed round. It's a $7 million seed round, June of 2024. It's not that long ago.
Really not that long ago. A lot has happened. I feel like I was maybe like a decade of my life.
Exactly. 9 months later, you raised your 50 million Series A. And then today, you're announcing you're raising 150 million Series B. That's incredible. Congratulations. Thank you for letting us partner with you on that journey. And it has been a journey. We were talking earlier about just, our first coffee chats back when you were still just thinking about what to do next. And it's just amazing to see how far you've come. You were very clearly focused on assembling the best set of people, whether it is, Dan, one of your co-founder, or someone who you had years of experience working with from your prior time together at Ripple Match. I could tell even from the first time that I met both of you together that you guys just sort of fit like, I don't know what the analogy is, hand in the glove or some kind of thing with hands and gloves.
Yeah.
It was a fit.
Yeah, I worked with him for so many years now, and he's just unbelievable at what he does.
And then Tom, just like a genius and someone who has contributed so much, as having started the interpretability team at DeepMind and among other accomplishments. And it meant a lot that someone like him would want to kind of join you in this endeavor. There's lots of partners that you've had the chance to work with, whether it's co-founders, but also investors. How important is the capital stack that you've assembled to go after this vision that you've articulated?
I think just deeply important. I mean, my last company was a hiring company, so this is just like building the best team is kind of core to my DNA, and what I spend a really large percentage of my time thinking about. And I spent a lot of time recruiting, and I've spent a lot of time recruiting in the last decade, and just the team and the people are really everything in a company. And I think we took a really similar approach to choosing our investors. We had the opportunity to choose from a number of investors in every single one of our funding rounds, and we just brought along the people and chose the partners that we just deeply trusted, that really got what we were trying to do. It's really easy to take a maybe short-sighted view of interpretability, not go for the really big kind of pushing forward of frontier interpretability techniques. And I think choosing the right partners to go on this journey with, that we just deeply trust and can get along with, is just really, really important.
I'm super grateful. Lightspeed is super grateful that you picked us to work with you from the very beginnings of this journey. 3 fundraises in roughly 20 months is it's a lot of activity.
Yeah, I spent a little bit too much time fundraising, not enough recruiting, obviously, but yeah.
You're doing something right. So there's a lot going on at Goodfire. There's a lot going on in interpretability broadly. There's a lot going on in AI broadly.
Mm-hmm.
As you think to the future, maybe kind of paint a picture for where the field of interpretability is going. What breakthroughs are on the horizon, either coming from Goodfire or elsewhere, that get you most excited?
I am deeply excited by and motivated by this vision and future of intentional design that we're creating. I think that's just the future of interpretability, where in order to be most useful, we just have to be part of molding and steering the training process of models, such that we can craft the systems that we actually truly want. That's where we're spending a bunch of our time, and we'll announce a couple of key new products and breakthroughs really shortly. Yeah, we're just hugely excited about our new ability to really edit and steer these models.
Anything that worries you?
I mean, these models are getting good so quickly. When Claude Code first came out, that was a little bit of an oh shit moment for us, across the entire company. We were wondering, do we have enough time? Do we really have enough time to kind of actually knock the future into the world that we really wanna see? And, going back to the urgency of it all, I really do see that, and feel that every single day where these systems are getting increasingly capable and impressive. I just really want to make sure that we kind of change the paradigm of how we craft these systems such that we can understand them and intentionally design them.
What are the big challenges, not just for you, but even just like the field broadly?
I think that we're still in the very early innings of being able to understand AI models. We can extract kind of a lot of concepts from models right now, but we're still just scratching the surface of, the quality of interpreter tools that we have, the quality of the representations that we extract from models. And we are just fundamentally bottlenecked as a field on talent, on compute, on resources. There are just not enough people who are curious about these problems that want to kind of dedicate their lives and their careers to solving these problems. It all comes back, I think, to hiring. How do we just bring on the best possible talent, the best possible people that maybe aren't directly in interpretability now, but are, training models at bigger labs, who want to and are curious about how these models really work and who want to play a part in the future that we're creating, not the one that currently exists.
One of the things that got us most excited, just on the talent point was, to your point, there's just never enough people
Yeah.
who are, really understand this and are deeply passionate about this.
Maybe like a few hundred researchers focused on this full time right now.
But by being this sort of lighthouse company, an independent company going after this problem and dedicating 100% of your time to just this problem, you can really become the predominant place for this kind of talent
Yeah.
to work. And I think you've done that in such a short period of time.
Yeah. Well, we have $150 more million to go and hire the best possible folks in interpretability research and engineering. And it's not just researchers, it's engineers, it's go to market, it's operations, it's, really across the board. Yeah, let's go. There's a lot of work to be done. And I feel like there's people out there that probably kind of see the future that we do, that want to shape it the way that we do. And I think a large part of my job is kind of, yeah, like almost lighting the beacon of interpretability here in San Francisco. If you see the future as we do, like, come on, let's go, let's get to work.
No shortage of things to be done. But on the theme of lighthouses, beacons, and I guess just bright lights in general, is there a North Star that you would highlight for your kind of next phase of growth?
Yeah, the North Star is intentional design. Like, how do we truly understand and intentionally design these systems as we can with written software and building the reliability and trust in these systems that I think we all really want and desire. And in many ways, I think of what we're doing as building a bridge between an AI mind and ourselves. It's most obvious that we have no bridge right now between a genomics model mind and our own. There's like a bigger, gap to bridge, but also being able to shape these models, we want to be able to give feedback directly into the mind of an AI model on why it did something wrong. There's almost no information that you're communicating to the model when you're giving it reward right now. But we are really building the bridge where we can actually say, you got the answer wrong for this reason. You should be thinking about this as you're generating your response. So the why really matters. Why a model gets to an answer, I think, is more important than getting the answer right. So you get the right answer for the right reasons rather than the right answer for the wrong reasons. That's really the future that we see, where we can go that direction to AI models and really give natural language feedback to craft a model. And the other way around, this idea of superhuman knowledge transfer from AI to humans. As AI becomes superhuman in an increasing number of modalities and domains, that's going to be increasingly important, or else we'll be left behind. Interpretability really is the only way that we can transfer knowledge that AI models have about our world that we don't have back to humanity. So this is going to be one of the best ways to progress scientific discovery and knowledge very, very soon. This kind of all started when Tom and his collaborators at DeepMind were interpreting AlphaZero, which is better than any human chess player alive. And they got a chess grandmaster to be on their paper and taught him how to play chess more effectively in very narrow positions, but it was just kind of that first case of human AI to human concept transfer. And I see that happening really across the board in every modality where AI has a fundamental advantage over humans.
Awesome. Well, chess tutors for everyone, I guess.
Yeah, that's right. Superhuman chess tutors. Yeah.
Exactly. Eric, thank you so much for doing this. It's like a really special moment for me personally. I know it's special for Lightspeed broadly. Again, we really appreciate you working with us. We're just really grateful for the partnership and congrats again from all the success so far.
Thank you. This is so much fun, and also just like deeply grateful for the partnership from the beginning. And it's still really just we're still getting started. There's still a lot more to go and build, and super fun working together.
Yeah, good. Well, I would say roll up your sleeves, but your sleeves are already
Our fearful stuff.
as they always are.
Yeah.
Very good. Thanks, man.
Cool. Thanks.